the working of AC generator or alternating current generator. This is how the electricity which we receive, the main electricity, it is generated in this principle, on this, based on this principle that at the power station they have these large rectangular coils and a magnets. So when they rotate the coil, there are different ways to rotate the coil. Like example, in a hydroelectric power station, there is a turbine. The turbine is connected to this coil. The turbine is connected at this part. So when the water flow, that turbine rotate, and as the turbine rotate, it rotated this coil. And when there is a coil rotation of the coil, there is a change in magnetic field which will induce EMF. Same way in nuclear or a coal power stations, first they convert nuclear energy to heat energy or chemical energy to heat energy, which is used to convert the water into steam. And when this steam collide with this turbine, it will rotate the turbine. As the turbine rotate, the coil will also rotate, and as this coil rotate, there will be a change in magnetic field which will induce EMF. Same way the wind turbines, the same principle, wind turbines are working, or windmills or wind turbines. So when there is a moving air, wind is there, that collide with a blade of this turbine and rotate the turbine, and this turbine is connected to a rectangular coil, and due to the rotation, of the coil, there is a production of electricity. All power stations does not require water, like hydroelectric required water, nuclear and coal. But like example, if you have a solar power station, it does not have any moving part, it does not have turbine. Directly the solar energy, heat and light energy, is converted into electrical energy. Same way wind turbines are not using water, it is using a kinetic energy of the moving air or wind. So basic idea, even you can also build a small AC generator at your home. What you have, a simple thing, what you need a permanent magnet. You just have a copper wire, and if you rotate or move this wire, the change in the magnetic field will induce EMF or current. So what happens when the coil rotates? It cuts the magnetic field lines, and so EMF induced that make a current flow through the coil. And as the coil rotates, each side travel upward and downward and so on. So magnetic field is continuously changing, so the current flow backward and forward, and that is why we call that as alternating current, because the current which continuously changes the direction, we call that as AC. And if you want to find the direction of induced current, what we use a Fleming's right hand rule that already we discussed in the last session. If you want to increase the induced EMF, if you want to produce a larger current or voltage, we should use a coil with more turns, we should use a stronger magnet, and we should rotate the coil faster. Now, how these factors will affect the output? They all increase the output voltage. Voltage and current graph for AC generator, they are identical. Example, originally on y-axis you have a voltage or current. This is a positive voltage. Example, I'm using a numbers to explain the idea, but you don't have to write the exact numbers. And this is a current produce or voltage produce. One cycle, two cycles, Now, what is the time period here? Time period means time to complete one vibration. If the x-axis is in seconds, what is the time period? Time to complete one vibration. So time period is 1 second. Now t is equals to 1 second. Or if it was 0.1, 0.2 and 0.3, then the time period will be 0.1 second. What about the frequency? Frequency is reciprocal of the time period. So what about frequency? 1 divided by time period or 1 divided by 0.1? What is the frequency? That is 10 hertz. Now, what will be the effect if we increase the frequency of or speed of rotation? So if we rotate the coil faster, if we move this coil faster, how it will affect, or what will be the effect? Because if we move it faster, it will produce higher voltage, shorter time period, and high frequency. So the frequency, the number of vibration will increase, the voltage output will also increase. So when we sketch now, I will use the same grid to sketch part A, like example. So what happened? The higher induced EMF, and there it will have more vibrations. So induced EMF increase and the number of the vibration will also increase. So it will affect both things. But what will happen if we increase number of the turns or strength of the magnetic field? So if we increase the number of the turns or if we use a stronger magnet, then it will only affect the voltage or current, but the time period and frequency remain same. So if we use a stronger magnet or we use more turns, but speed of rotation is same, why it increases the voltage? Because if you use a stronger magnet, there is a greater change in the magnetic field, or if you use more turns, each turn is producing small current, but overall the current will be, collective current will be high. That's why it will only affect the value of the current or voltage, but it will not affect the time period. The time period will remain same. So you will find sometime a question, they say sketch a graph if the speed of the rotation is increased, or if we use a stronger magnet, or we use more turns. So if we change the turns or stronger magnet, that will only affect the induced EMF. If we move it faster, then it will affect two things: the length of the cycle, like the time interval, the frequency, as well as the value of induced EMF. Is it clear now? The AC generator. The AC generator and DC motor, they look similar, but how to distinguish, how you can identify? For AC generator, you don't have any supply here. But if you have a DC motor, increasing a number of turns, like using more wire in the magnetic field, and increasing the rotation speed means moving it faster. The AC generator and the DC motor, the difference between them, as you can see, in DC motor, what you have a supply here. They both look similar, but in DC motor we pass the current and it rotates, and in AC generator we rotate the wire and it produces a current. So both are actually opposite of each other. A DC motor converting electrical to kinetic, and AC generator converting kinetic to electrical. Then the last topic of this magnetism is methods of magnetization and demagnetization, like how you can make a magnet. If you want to make a magnet, there are two ways to make a magnet. Number one, the electrical method. In electrical method, what we do, we know the current is having a magnetic effect. We know the current is having a magnetic effect. So what we will do, we will take a piece of material which we want to magnetize. Example, in the beginning the domains are not aligned, and to make a permanent magnet we use steel, because iron is a temporary magnet. It will behave like a magnet only in the presence of external magnetic field. This material, like example, you have a steel and you want to make it magnet. So what you can do, you can use a direct current, a DC. So you wrap the wire around, so positive and negative terminal. So when we pass the current is having a magnetic effect. So when there is a current, there is a magnetic field. So what will happen, as you are passing a current, there is a magnetic field, and how to find the direction of a magnetic field due to this current? Your fingers will turn in the direction of the current. Your thumb will point towards the direction of North Pole. So fingers turn around, the thumb point towards the North Pole. So what happened? When you pass the current, it will affect the arrangement of the domains, and domains will align according to external magnetic field. In the beginning they are not aligned, but when you pass the current, the domains will be aligned according to the external magnetic field. So as they are aligned according to external magnetic field, the material will behave like a magnet. And this is known as electrical method to make a magnet. Normally this technique is used to prepare a permanent magnet. So magnetizing by electrical method, what we do, we take a steel bar, place inside a solenoid. Solenoid means a circular wire, and we pass a direct current, DC. A strong magnetic field is produced and the steel bar is magnetized. As you can see here in this picture, the direction of the current, this is the direction of the current. Why AC will not work? Because alternating current changes its direction continuously. Example, if you try to magnetize by alternating current, so these domains are not aligned, and if you try to magnetize by AC, so for AC, first left hand side positive, right hand side negative. Next moment what happened? The direction of the poles will also change. Right hand side will be positive, left hand side will be negative. So the direction of the poles, magnetic poles of AC continuously changes. So first this side will be north, other side will be south. Next moment this side will be north, other will be south. So if this is a domain, this domain will continuously vibrate because the current is changing, so the direction of the domains is also changing. So as the direction is changing many times, what will happen? The domains will not get chance to aligned or arranged. Some domains will remain in opposite direction, some so they have random direction. That is why AC current cannot be used to magnetize or make a permanent magnet. We always use a direct current or DC. This is normally what we use to make a permanent magnet. There's a magnet you cannot see. This is a wire or a solenoid. Here we connect a positive and negative terminal from the battery. We pass the current and we place a material which we want to magnetize inside. And after some time, we switch off and take out the material in which the domains will be aligned and it will behave like a magnet or permanent magnet. There's also another method to magnetize. Second method is called stroking. Stroking here refers to when you rub an unmagnetized material by a permanent magnet. Like the domains are not aligned, so what you will do, you will take a permanent magnet, any pole you can take and rub many times in one direction. Repeat this procedure, rub this many times in one direction. So when you rub this, a time will come when these domains will be arranged or aligned. So once the domains are aligned, the material will be magnetized. This method is known as stroking. So first method is to magnetize is by DC. The second method is called stroking or rubbing the material by a permanent magnet. One is single touch, another one is divided touch. So here what we did, we rub and then we repeat again, then we repeat again, we repeat again, and continuously we are doing the same technique process until it will be magnetized. And here we are rubbing with opposite poles. Why this will work? Because the permanent magnet is having a magnetic field and this material is having domain. So this magnetic field of a permanent magnet affect the arrangement of the domain and cause the alignment of the domain. So when the domains are aligned, the material will behave like a magnet. But this can only be used for steel because iron cannot be permanently magnetized. It is a temporary magnet. Is it clear? The methods of magnetization. The first one is electrical method and the second one is stroking. Is it clear to everyone? The two methods or techniques which we use to magnetize a material. Then how to demagnetize. These are the two methods or technique to, yes, to make a permanent magnet we cannot use iron. For example, if a student is using an iron here, a piece of iron, and passing a current. So if there was an iron and you are passing a DC or a direct current, so this current produces a magnetic field. When this current produces a magnetic field, north pole will be right hand side using a right hand grip rule and south pole on the left. So if this was an iron, it will behave like a magnet. But once you switch off, you open the switch, the circuit break, the iron will be demagnetized because its domain cannot remain aligned for a longer period of a time. So iron, if you use iron, it will be temporary magnet, not permanent. To make a permanent magnet, it must be steel. Then methods of demagnetization. Basically, if you have a material which is a magnet, to demagnetize, what we have to do, we want to disturb this arrangement. So how I can disturb this arrangement? How I can disturb this? I can heat it, because when I heat, the molecule will vibrate and it will disturb this. Or I can also hammer this. Hammering also disturb the arrangement or alignment of the domains. And what else? What I can do? I can wrap the wire around and I can pass an alternating current. Because if I pass an alternating current, what it causes? It causes the domains to vibrate. So as the domains are vibrating due to AC current, a time will come when these domains will be random. And when we are using an AC current, we should gradually take it out, because some part, so that some part experience a stronger magnetic field and some parts will experience weaker magnetic field. So methods of demagnetization: demagnetize by alternating current or AC. So if you want to demagnetize a magnet, to be demagnetized, place in a solenoid. Solenoid is connected to AC supply. The magnet is withdrawn away from a solenoid in east-west direction. Why specifically east-west direction? Why not north-south? Because if you take out this magnet in a north-south direction, then maybe the earth magnetic field might magnetize this. So you want to reduce the effect of earth magnetic field. That's why you should move in a east-west direction. As you can see in the picture, so we have north, south, east, west, and we are taking the magnet out by passing an alternating current. This was a question in the yesterday's paper 4, that how we can demagnetize by, or why the technique will not work if we are passing a AC current. So what we should do, we should gradually take this magnet out from the magnetic field. The second method, you can heat it or you can hammer it. So both cases, it will become weaker and it will lose its magnetization. Is it clear, the methods of magnetization, or how we can make a permanent magnet? Sorry, how we can first making a magnet and how we can demagnetize. So this was about magnetism. So we completed block 4 as well, which is electricity and magnetism. Tomorrow we'll do multiple choice questions related to magnetism, so you will have a better understanding of this topic. Any question related to the class today? If you bought a permanent magnet and you hammer it, but you should place in a east-west direction and continuously hammer it, it will weaken its magnetic field, and then eventually it will become, or it will be demagnetized. So I'll end the session and share this recording with you.